adders and subtractors. You can find the adders and subtractors in the arithmetic in Logisim, and let's grab the adders first. So here I have an adder. Adder is basically add two numbers together. Okay, make it a little bit bigger so you can see clearly. So adders basically add two or multiple number, whatever it is, it just add together. But it's only have two inputs. We cannot change the input, so it's only to add two numbers and give the output. Okay, for let's look at the example. So here you see this is in 8 bits. So you can change the bits actually. You can change it to 1 or you can change it to 4 or whatever. So 4 is, let's try 4 bits numbers. So here I change this one to 4. If it's 4, then input also has to be 4, then only this one match, because you see this orange line because of the incompatible bit widths. So I have to change this one also 4 as well, and then I copy this one and create one more input, paste it right here, and then for the output you can either put an LED matrix or just an output. So if you put LED matrix, you need to just get a single output. So change this matrix rows into just 1, and then matrix column into just 1, and matrix column into 5, because when you have 4 bits added together, the answer could be a 5 bits because there could be an overflow. So we need to make it a 5 bit, and then this one should be a row because we just need a single output. So make it a row, and now you only get single output. Now you connect this one with this, but this is a 4 bit, and if you connect it directly, it is incompatible with, because this is 4 bit and this is a 5 bit. So in order to make the bits match, you have to put a big bit extender. That should be in the wiring. Okay, you click this one and put a big bit extender. In the bit extender we want to convert a 4 bits into 5 bits. So we put 4 bits to this side and then 5 bits to the other side. Okay, now let's change the inputs and see what happens. So here for example, if I put 0001, and that is, in binary just 1, and then if you put one more one, 0001 plus 0001 is 2. So here you see 5 bits binary number, that is 00010. This green light represents 1. If you want to just clearly see the decimal, clearly see the binary representation of it, you can just remove this one and then add an output, exact output here, but the output has to be 5 bits. So you have to change this one into 5. Okay, now you can see 0012. For example, let's try another example. Let's say I'm adding 1 and 4, so I should get 5. So here 00101, so this is 4 and this one is 1 and 5. Okay, so that's the adder. Now let's look at the subtractor. Subtractor, again, you go to the arithmetic and grab a subtractor. Let's try the similar thing. So this one is currently 8 bit. I convert this one to 4 bit, and for the subtractor, let's put two 4 bits input, one here and then another one right here. Okay, for the subtractor, the output cannot be more than 4 bits because there's not going to be an overflow. Overflow only happens when you add two numbers together. So for the subtractor, there are not going to be any overflow, so you can keep the output also as a 4 bits number. So here we put the output and just convert the 4 bits. Since all of them are 4 bits, we don't need this bit extender. Okay, but in the subtractor there's one more thing that, for example, if I have 1 here and if 4 here, 1 minus 4, that's a negative number. So to find out it's a negative number, because if you just put 1 and 4, you're gonna see a number, sign number, but you don't know whether it's a negative or positive. You might think it's a positive. So to identify whether it's a negative or positive, you can put an LED light. If the LED light turned on, then you know that's a negative number. So you put a LED light and connect this wire with this one, and let's put a negative number. So if I put 1 minus 4, it becomes red. If I put 4 minus 1, it doesn't become red because 4 minus 1 is a positive number. 1 minus 4 is a negative number. So you get the LED light turned on. And 1 minus 4 is negative 3. But here you see a big number. Because this comes as a signed number. But to find the exact number, what you can do is you can do the 2's complement. 2's complement is basically you do the 1's complement and then add 1 to it. So here how to do the 1's complement is you turn all the 1's into 0s, 0s into 1. So if you do that, then this is going to be 0, 0, 1, 0. And then if you add 1 to that, that becomes 2's complement. So 0, 0, 1, 0 plus 1, that's 0, 0, 1, 1. 0, 0, 1, 1 is representing 3. And we know this is a negative, so it's a negative 3. So like that you can find out what is the exact output is. And that's it for this video. Thanks for watching. See you guys on the next video.